Weird being here on the edge of things, but we'll make it work. Thanks for coming to this talk. Of all the great ones you could have selected, it's glad to have everybody here. And I hope you learn a lot and get inspired to try out something new, getting out of your comfort zone a bit. So who am I and why should you listen to me? I've been building websites for about 20 years. I've seen a lot of rubbish. I've built a lot of rubbish. I've also built some pretty cool stuff in the last few years. And that's what I'm hoping to share with you. So we kind of need a little bit of a backstory here. Is if you've built websites for any amount of time, you'll know that we went through a lot of stuff. And we went through an insane amount of JavaScript fatigue as well. Mood tools came into the news recently with the whole array.smush thing. But it's kind of a reminder of the journey. And it's kind of important to reflect about this as well. Like, what is the web? What are we building for? And how do we make our lives simpler in a world that's really getting more and more difficult to build for, and the decisions are more and more. So instead of dwelling on the past, I want to kind of say, like, let's look at the future of single-page apps, because they're not going anywhere. So we kind of need a better way to deal with them. And one of those ways to deal with them is to use immutable data structures. I'm sure everybody's kind of seen this trend come up more and more and more and more. Pushing JavaScript into this weird world where it's not exactly comfortable. Another way, and the functional programming ideas that's coming with the libraries, and especially like React and Redux is kind of leading the absolute charge there. And reactive interfaces and data sources. I haven't myself really worked with the RX, JS kind of stuff, but very, very popular as well. That you're seeing events flow through your front end, data streaming into your front ends or into your systems, and just kind of reacting on the fly the way you need it. Very nice abstractions. What's also important is stuff like tree shaking and dead code elimination. And that's kind of like coming into the Webpack and Ember world and stuff fairly recently, but it's stuff that's been around for quite a while. And it's especially, I mean, maybe not in the Valley, but yeah, it's important if you're like shipping something out to somebody where, you know, they're paying 2 rand a meg for data. Like, that's insane. So you've got to be careful with what you ship. And code splitting, the same kind of thing to optimize. And it's just about like being faster. On the React side, this is an insane list of 82 libraries for dealing with with immutable data and Redux. 82. Like, that's crazy. This was a list of 50 when I did this talk the first time last year. And that's how quickly it's moving. And this is just one very thin slice of the JavaScript world trying to deal with immutable data. So I want to reframe it ever so slightly. So what we're looking for is less mutable state. If you've worked with any one of these immutable frameworks or ideas, you've kind of seen the benefit of this when your data never changes. There's some really good stuff that happens. Your life becomes a lot easier. We want less synchronization. Boils down to the same thing, but from a different angle. If you've got like a bunch of events, people are clicking, things are going crazy in your system, data streaming in over WebSockets. There's a lot of stuff you just shouldn't be thinking about. You should still just be focusing on building your app. Again, it's that smallest possible payloads, and it's important why I keep hammering on that one, and the fastest possible delivery. But in a way, it comes down to inoculating against the effects of time. So this is time to develop, time to debug, time to deploy, time for people to experience your app. Once your app's running, managing state over time within it. The time's not something we deal with. At worst, we have to deal with time zones. That's like a single point that you're dealing with. We're not treating it as a continuous flow. And something interesting to think about and reason about what becomes possible when you think about it that way. So what I want to introduce to you is a framework called Reframe. And Reframe is a pattern for writing single-page apps in ClojureScript. Reframe is a wrapper around React. So you kind of get the best of React. And React and ClojureScript is a beautiful marriage, like a functional language with a great framework that does its best when it's working with immutable data. Absolutely fantastic. And so what is ClojureScript? So ClojureScript is a version of Clojure that compiles to JavaScript. So you can target the browsers, or you can target Node with the same language. It brings all the best of Clojure, which is a functional immutable language, to multiple target platforms that you can use. And it doesn't just compile to any JS. It compiles to the most boring ES5 variant you've ever seen in your life, so that they can hand it over to the Google Clojure compiler, Clojure with an S, to optimize the code and give us all these benefits that people are seeking out in other parts of the community that Google's been doing for 10 years. Plus, all their main properties, the code eventually flows through Clojure to make things lighter, faster, get rid of dead code, do the tree shaking, split the code up into different models, move code around to optimize it. It's a fantastic toolchain that you just get for free. So that then what's Clojure? So Clojure is a Lisp, functional programming, dynamically typed, strict type, great fun to work with. It's 10 years old, or turned 10 just late last year, so it's been around the block. Who's ever worked with a Lisp or seen a Lisp? Okay, quite a few hands. So Lisp came from this guy, Mr. John McCarthy. Who ever thought about where the if statement came from in software? And can you imagine writing software without an if statement? I was thanks to this guy 60 years ago when he made Lisp that he came up with an if statement. Before that, you literally had completely independent programs that just ran A to Z, end of story. That's what they did. So everybody should be grateful for him. And he's always focused on keeping computing fun, which is an interesting idea. So people tend to make a lot of jokes about Lisp. But the funny thing is, Lisp is often emulated and pillaged, but it still hasn't been duplicated in any way. It's been 60 years. This language is still around in very different, various incarnations, and still being used in very serious places. It's being used in satellites, in Boeings on the planes to help fly the planes, not even from the ground. NASA does stuff with it. Walmart, PayPal, it's everywhere. And eventually, there's a few jokes. People also say, any sufficiently complex system would eventually develop its own, half-baked version of Lisp inside it to start dealing with its own issues. It's got almost no syntax. I know people love hammering at the parentheses. It's like the common, but this is very little syntax. I really have a hard time going back to languages that I've used for years that I used to love, and now I just go there's so much noise. It's impossible. And an interesting thing that I'll show through more slides is your code is data. The code you write and the data structures that Clojure works with is exactly the same thing. So Clojure ends up reading its own code as data and evaluating that. It's a very, very powerful idea. Also a very different idea. But back to Reframe. So, like I said, it's a functional programming framework around React. So if you've done any kind of React work, the stuff will be very familiar and very simple. And it's a very easy way to learn React, actually. I go back looking at JSX code, and I'm like, it's a bit heavy. But it's been nice to learn React through a proxy. Makes it simple to deal with. Underneath is a library called Reagent. That's the one that does the heavy lifting for us with React's components. It's amazing in the sense that it can be faster in certain situations than React itself, because the reagent guys, because we've got immutable data, they kind of can take some parts of the React code out and replace it with code that's aware of immutability first class. And a lot of checks and balances don't need to happen, and you get something really light and speedy, if performance is important to you. I mean, React's already fast, so it's actually immeasurable. It's a data-first approach, and that's kind of key throughout this whole thing. Not code comes second. Data, our app state, everything is just data. The better we can keep it that way, or the more data we've got and the less code, the more easier to debug and reason about. Very unique thing from Lisp. And it runs on a perpetual loop, and I'll show what that looks like now. It's also been around a while, like at the start of December 2014. So it's been battle tested and used in some interesting places. So in an immutable world, we need a single source of truth. And in our world, we're going to use one giant atom. The atom it's just semantics. It doesn't matter for this, but it looks like a hash map or a dictionary. I hope the code is. Can you see the pink? Okay. So it's a dictionary or a hash map or a hash, depending what your language calls it. It's just a map in Clojure, and there's just one of these for the entire application. Similar to how Redux has its single data source. Then what we end up having is something like the water cycle, where data will just keep flowing forever. We'll have events going the one way, they'll have an effect on the world, and the views will update, and the user interacts with the system, or data comes in from the outside world, and events fire off again, and we just end up in this ever simple perpetual loop of doing things. To make it a bit more concrete though, it looks something like that. And that's about as complex as the system gets. But there are events getting dispatched. There are handlers for the events that would either update local state, simple handlers, or there could be more complex handlers that actually have side effects. They're talking out to the outside world. They're making AJAX requests, they're tampering with local storage, whatever you need to do. I mean, your app's not a silo, it's not an island. It definitely needs to reach out. Then you've got the single point where you've got now an opportunity to change the world for your app. So one place where you mutate your state, and then you've got a cascading effect down of views updating and materializing in kind of what that view of the world should be now after everything got applied. And this very, very simple loop just goes on over and over and over again. So I'm going to take it from the bottom up, given that graph. A subscription looks like that. A subscription is a way to read data. And it's distinctly decoupled. It's well named. Well, in this case, it's poorly named, but I mean, it's a well-named thing that from the outside, the application references. So your views don't have any idea of what the internal shapes are. And your views should be very, very stupid. They just want to say, give me somebody's name, I need to put a name here. Like, hi, Ken. That's it. I just wanted Ken, nothing else. I don't care where it comes from, just give me this. Or give me the list of customers, or give me anything, and I just want to render it. That's all they care about, is then rendering it. So that is the way that we can register a subscription, give it a name. We've got a little anonymous function, that's what the FN does. It gets called with one parameter, and it's the global state. And we just reach in, and we pull out the counter value. That's all we want. Just want the counter, and that's going to flow up. We can also have dependencies. So you can start thinking in an Excel-like model of a bunch of cells starting to depend on each other. So if you really want to be a little devil, you can make an off by one subscription. So it depends on the original counter. Now, instead of getting the world, it gets what it depended on. In this case, it wreaks havoc and returns the value. And you've got something. But that is quite a poor example. So let's look at something slightly more involved. Now, if you've just got a table with a list of customers, and you want to be able to sort by any attribute and in any order. And that's something that could either be a non-trivial problem, if you've got the tools to express it, or you've got to start holding on to a hell of a lot of stuff to do something as simple as that, to keep a user happy. It's just table over data, and they need their way to get to something quickly. So you can create a subscription in the end that's like the sorted list of customers that just sucks values in from everywhere else. It can be manipulated, and it just works. At the bottom, I'm going to show what the AppDB would look like with this kind of data. So there's a list of customers, and they've got some properties like a name and an ID and whatnot. And then the sort by, you can see it's just the angled bracket. But this is not kind of the nice thing about like functional programming with a first-class language. Like that's the raw function for sorting. And you can just flip between the greater than and less than signs in your app state as you need your sorting. And things become very, very terse. And ooh, that's nice. Thank you. But we need to update state. That's absolutely critical as well. So how we handle updating state is registering event handlers. And their job, again, is to take some kind of feedback from the outside world and change the world. And this is the kind of place, I'm not going to do it justice in examples, but this is kind of where your business logic and rules and stuff would start living in. Somebody's filling in forms, all the validations right, and you kind of stop stuff from polluting your world until you're ready to get it in. And that's what these little guys do. So in this case, again, it's got a proper name that the rest of the app will reference it by. It gets called with the world. It makes a change to the world. In this case, it simply says, listen, here somewhere in that database, that giant dictionary we've got, there is a counter key, and increment it. And it will simply call that function inc with the current value, and it will be one more. Dead simple example. But you can imagine this is where you start appending valid customers into your customer list, or whatever kind of other actions you need to handle. You build up an AJAX request, and you send it off. And you control the edges of your system there. You can add, so what's added here at the top now is the idea of a little interceptor. This is like a mini middleware. If you've ever worked with a web framework, especially on the server side, we've got like this nice notion of middleware that the request can flow through all the way till the handler, and every piece of middleware is an opportunity to fiddle with stuff and maybe augment it or do some checks, and then it flows back out to the client. Because these event handlers are so key in your system for actually doing the work, you can add these interceptor chains to do some interesting stuff with it. But in reality, for the most part, is you just want useful debug stuff when you're busy developing. You want to kind of see what the world looked like before somebody clicked the button, and you want to see what the world looks like after the button. I'll show you what this looks like. Oh, sorry. Then, earlier I harped on why it's important to be able to lean on the Google Clojure compiler. Is the only change now at the top is that top little flag going when goog.debug. When you build production code, production version of your app, the Google Clojure compiler will pick that up, and it goes like, no, but that constant is now false, and all your debug code gets stripped out, and you've got a smaller payload. So anywhere in your application where you've got this, so you end up having nice sprinkles of debugs, and you can leave your print statements if that's the way you want to debug, or anything you need in your code at all times, and a very, very smart compiler will go and strip this out. And this has a ripple effect throughout all your tools. If you start using logging libraries, like a proper logging library to collect and roll up the data, you can just go, I'm never going to log, debug, or trace level in my production build, so simply get rid of all the code that even calls it. So it's not even becomes a Boolean like, oh, logging's not disabled. Remove those statements from the code completely. And this is a ripple effect throughout all the libraries that you depend on. Everybody plays this game. It is super, super useful. I want to show you what these views start looking like. So we've kind of seen that there's a way to get values, and there's a way to change the world. So we can read from the world, and we can get values, but it's not very useful if you can't render it. So this is a simple vector or an array where the notation we use, well, this is just one style of notation. I mean, you've got many other template engines and stuff, but what makes this one nice is you just define nested vectors, and the first element is you describe the piece of markup. So in this case, a div with those two classes. And inside it, an anchor tag with its classes, and then inside it, finally, a value that comes from somewhere. The only analogy I had was to use handlebars on the right. But that kind of, does that make sense? That's something you can kind of see and read, how this thing composes. What's really powerful about it, it's just a data structure. So it can be manipulated like any data structure in any circumstances. It's not markup. Somebody else in the background turns it into markup for us. So if we want to render that up into a React component, we make it a function, we give it a name, so it's the counter is the function name. We need to get that value out of the subscription, so we simply subscribe by name to counter. That was the proper name we gave it. That's all our interface cares about. It doesn't care where that value comes from in the end. It just wants it, and it will then render it out at the bottom. Anytime the results of that subscription changes, this component will re-render, just like React would do it normally. And it just cascades all the way down the tree as far as it needs to. We can also nest components just like you do in React or JSX. In this case, we now have a main panel that at the very end they just mounted the counter in. Same pattern, subscribing for value from the database. Doesn't care where name comes from, it just wants to render it out. So again, as the markup as data structures, the previous one I left it out, but now in this one you can kind of see if your second argument is one of these maps again, you can just start giving attributes to the HTML elements that you created. Like we've got the nice shorthand for class and IDs, but at some stage we want to do alerts. Or we don't want to do alerts. But that piece also there shows like a little anonymous function. That's what the hash is in front of it. It will just fire off when you click it. And it kind of shows the interop between JavaScript. And what that line basically says is we're calling the alert instance method, for lack of a better explanation, on the window object. And I kind of want to show that off because it's super pragmatic. Unlike a lot of other languages that target JavaScript and try and hide JavaScript from you and push it away to the edges and go like, no, you're living in this utopia of like you write our language. The ClojureScript and Clojure the same. The Lisps are very pragmatic at interacting with their host. They acknowledge that they've got a host and they've got tools for you to do what you need to do. It gets out the way so you can do stuff. And especially that means you don't need another language just for expressing stuff like handling on-click events. But I mean, if you want to do it properly, you want to say, like, dispatch the increment count. So keeping our body nice and tidy, we could just put it in a tiny little function. Just call it a variable, and then simply use it in our on-click, and it will fire. And we will feed our loop. The user's got a means now to push our loop forward. So the effect handling boils down to taking all the effects generated previously. This is kind of subtle but important, but if there's like a lot of stuff coming through, they kind of get batched up on a request animation frame style loop, and they'll all get a chance to process in the order that they came in, and they'll work towards materializing a new world. And then that new world just becomes the next state that the app takes forward. This is great because it's completely debuggable. I'll show you in the demo. It's auditable, which is key, especially during development. We try and figure out like just what's going on. But you can imagine in a production system, you can have a piece of code that maybe keeps like the last 10 or 20 or 50 events running. And when you report an error into Sentry, Airbrake, or whatever other tool, Honeybadger, whatever you're using, you can kind of ship the events that led up to the problem with as well, which is absolutely stunning. No more guessing what happened. And it's also great you can do time travel debugging, because you can kind of like just move your app back to where it was and figure out what happened, which is nuts. And then finally the DOM. It's kind of nice. We don't need to worry about it. It's all handled for us. We just make these little vectors. Somewhere we need to attach something to the root node, and it's absolutely dead simple, which gives us a complete example, excluding the subscriptions and the handlers, which is sort of super simplistic of that. So that might have looked very boring, but I think if I couldn't quite turn it up to 11, because then I would lose everybody. But we've only just scratched the surface. What's nice about this whole environment is you get a browser-based REPL. If you've never worked with a language that has a REPL, I mean like really have a REPL, it fundamentally changes the way you want to build software and interact with the running system. Like having a live way to attach to something and type out code and get it executed is a game changer. And I don't mean this like Rails and Ruby's got pry, and I'm sure there's some Node REPLs. It's not the same thing. I mean, like we're actually interacting with your live system, and I'll show you an example of that. Hot code reloading that works, that is critical. So as you're busy building up these subscriptions and handlers, and you're changing your markup, as you save the files, you want to see your browser adapt, and your app get bigger. And you want to see it break when it breaks, and get good feedback, and go back. That's absolutely critical. Source maps with syntax highlighting. I mean, otherwise you couldn't. What's amazing is Google Chrome supports highlighting Lisp out the box. It's not even that you need any plugins or add-ons or anything. It's compatible with React DevTools since it is just React. I don't find that particularly useful, but I thought I'd put it out there. If somebody does actually use the tools and lean on the React DevTools, it's available to you. Nothing's hidden away. And yeah, like I showed off the great JS interoperability. And that extends to node packages, any packages. It doesn't matter. So that brings us to this. I kind of like this quote. The first experiment already illustrates the truth of a theory well performed by practice. Whatever can happen will happen if we make the trials enough. This is the precursor to Murphy's Law. I believe in Murphy's Law, so I have pre-recorded demos. So it's going to go fast, and this video is a bit old. I was trying to update it, but I couldn't get the same thing out. But I just want to give you a prep what you're going to see on the screen, because when it starts moving, it's not particularly fast, but it's fast if you don't know what you're looking at. So standard Chrome on the side, DevTools open on the side. Sorry, I never zoomed in. But you shouldn't worry about what you're not seeing in the DevTools. Just kind of see the activity scroll past in the console. On the right is our ClojureScript code in Emacs. And then as I start the video, I'm going to click on that refrisk, and it's going to pop up a little debugging window that I'm just going to move to the top right. And then you kind of like get the lay of the land and see how the system works and interacts. So debugger's out. In the white panel of the debugger, you can kind of get a view of your entire app state at any point in time. So you can kind of see the values. We can see Clojurians at the top. We've got a counter value. There's some other panels hidden there that you can kind of see what subscriptions are active. On the left, you can see the events. The events are streaming at the bottom there in the console, but it's just a little diff of the world as you're interacting with it. Click the buttons. More ways of seeing the event. You can inspect an event. So if you've got form handlers and you're passing more data with, you're not just calling increment counter, you want to see what happened. Now what we're going to do is we're going to add a new event handler for resetting the count, because this thing just goes up. At some point we want to start over. Just typing out the little function there, reset count, adding the interceptor, which is our debug output. And all we're going to do is replace the value of counter with 0 in the database, and that's our reset. Now, I'm changing to the REPL, and the browser reloaded without touching anything. And now, in my editor, I ran reset count, and we could see the events flow through, and the number went to 0. So I didn't do anything in Chrome. I'm running the commands from my editor and interacting with a live running system. I can get a feel for if it works. And now I'm kind of happy that reset count works, and I'm happy that int count still works. So now I can go and update my layout to actually add a reset count button. So there I make another little anonymous function to just dispatch the reset count. Select all that. Because the code is data and like a structure, I can just ask my editor, listen, you take this block and just add new square brackets on the outside and indent it for me, and then I'll go add my new ones in between. Add a button with an on-click. Give it some text. Now, as I save, I mean, if you keep your eye on the reload, refresh button, you'll see I don't press, it just appeared. There's the button. Can interact with it a bit more. Can hit reset count, and it just works. And that's the demo. And the scale's up. Like, the scales up tremendously well, no matter what size app you're working with. I mean, it's not without its faults, but it is absolutely a game-changing way to work. So things do go wrong. You get great feedback. You know exactly what's going on. You can configure that even so if you click on the line number, it can send a system command to take your editor to where it wants to be. But I'm generally kind of like more or less my cursor is exactly where I just screwed things up, so it's not far to travel. That's really useful. If you broke it so bad that your Lisp itself can't compile, you'll get a nice different message, and it just keeps telling you, I'm trying to compile in the background, like fix this until it works again. I mentioned you get source maps in the debugger. So there's an example of where I've got the debugger paused. Unfortunately, though, there we don't get the nice Clojure values. You kind of see the guts of the JavaScript that's running. But after you see it 2 or 3 times, and then this is kind of a very last resort, very, very last resort, because the rest of the tooling helps you so much. You can inspect your database, you can inspect your events, you've got debug divs flowing through as you're working with your system. So last resort, but completely, completely possible. And as I mentioned before, the React Dev Tools. If that's a tool in your toolbox, it remains, which I think is useful. So it always boils down to this. And I guess it's a different question for a front-end app, because it doesn't need to be web scale. But it definitely needs to handle complexity. I mean, none of us are in the game of building counters with reset buttons. Otherwise, we wouldn't be here today. Build complex apps. So you want to make sure that you've got the tools have got your back. So there's a lot of stuff that Clojure gives that I did simply not show you, because it detracts. But you've got namespaces. So you can, I've got counter, it's the most generic name possible, and we saw this morning like what poor names can do to a system. So you can now start namespacing these values up, that you can get more specific counters if counters are your business. So that really isolate things. You can start putting your functions, all your subscription handlers, your event handlers, any other functions you've got neatly partitioned in different namespaces. The demo is simplistic, but it allows you to scale up, and the different parts of your system won't affect each other as you work. Those components you worked on 5 months ago, they don't change. Nothing changed. And it's great. You can just keep running with it. It's absolutely dead simple. And you just stack on these namespaces, and the more you have, the better. Something I've learned recently, really. The tooling, I showed you now that Figwheel is an underlying tool that does that live reloading mechanic for us and shows the nice errors. That thing can be run for days, sometimes even weeks. The only time you actually really need to shut it down is if you add a new dependency to a project that doesn't get loaded by magic. Otherwise, that process just runs. You're finished for the day, you close your laptop. Tomorrow, you open it up again, it's up. Nothing happened, it just keeps on running. It's absolutely nuts. People don't leak state, no memory leaks, none of that. And I guess a big part of it's also because it's immutable data. And because the Clojure code itself is data, like replacing the whole world with fresh data as your code reloads. Also, it's like you don't have these kind of side effects, which is subtle, but it brings out this kind of joy while working. You interrupt with the existing libraries. So I didn't show an NPM or jQuery integration. It's quite boring, but I did show that little like just bridging into calling into the JavaScript world. And like I said, Clojure is pragmatic about it. When you need to interrupt, you do it. It's not hidden away from you. It's a great, great joy. It also means in this world you can just go pull in amazing React components that other people have built and use them. Why go and reinvent the wheel? And the NPM integration in Node proper is really getting good. And I think there's some people that's getting it right to run ClojureScript without the JVM in any capacity, which is also an interesting idea that I want to play with. You get the advanced code compilation out the box. You don't even configure anything. The ClojureScript build tools already drive this out, brings in all the dependencies for you. I mean, this is amazing. I've tried to use these codes a long, long time ago in Rails apps to build like super compressed bundles of assets. And it's a pain. And here you get it mahala. It's absolutely great. And if you think about that time to deliver an experience to a user, you can split your build artifacts separate to how you wrote your code, which is a bizarrely interesting idea, hard to explain. I've been trying to figure out how to explain, but if you imagine you've got your main app in a namespace, and you've got all your dependencies in other namespaces, you can tell the compiler, listen here, put this namespace and all its children in that file, put everything else in this file. It will make sure that all the code sits where it belongs and just tear it apart. And then you can independently fingerprint them, and your dependencies won't be changing that often. So on every deploy, at least you can like fingerprint, file expiration date, all that jazz on your big bundle of dependencies. And your tiny piece of app code will just be the only change that people have. And these things are just kind of like dynamic. They're not tied to, you've got one main include file for this tree of data and one different input file for this tree of data. The compiler handles it for you. You just simply go, this namespace, this file, this namespace, this file, the rest there. No matter as your app keeps on growing, like it just sorts it out for you. It's fantastically simple. The demo I showed you there, if you build a production deploy of it, it's 167 kilobytes. I mean, it's quite big for a Hello World, since it ships a lot of stuff with it. But it's got the base ClojureScript libraries in there, and it won't grow much beyond that point. It's kind of like if you've played with Go as well. A Go static binary Hello World is like 7 to 9 megs, depending on the architecture. But then it takes a lot of code before it starts climbing again after that. You kind of get the same experience. Another interesting thing, and I kind of put this on the end, but this is an up-and-coming feature in Clojure and ClojureScript, is this idea of Clojure spec. This is an absolutely fascinating thing that I think in the long run will change for software for the better. If you like, I'm not a types person. I completely if you bring strict types, I'm out the door. I can't reason. The world to me doesn't work that way. The word to me is loose, and there's always exceptions to the rules. There's not just a chair type. It simply doesn't work like that. Even within all these chairs that are supposed to be the same thing, we'll find an exception. But spec is a runtime validation of big data structures. And it's composable and inspectable, and you can do amazing stuff with it. Go read up about this thing on your own. It's absolutely just even worth the ideas of thinking about it. If you work with any dynamic language, this can be the future. So what that little snippet does is it basically goes and says, look, we've got a specification for counter. A counter must be an integer. It's this little predicate function. And our name must be a string. And our database must have, so it requires a counter key and a name key. So you can start composing these rules up of how you want your structure to look. So in a few months when somebody changes an API backend and you get some data in, and you had a contract on how the data should look, and it's a JSON blob, no type system in the world is going to save you from that, and that moves into your app state and you break your app state, you can put a barrier there to go no, this will fail. That is critical if you're working on big pieces of code. And that chunk there at the bottom, don't worry about the mechanics, but that's basically something I will just say, give me a piece of data, give me a spec. If it conforms, good. If it doesn't, I'll throw an exception. So I showed the interceptors before, and now I can just go and build a new interceptor that on every time your app DB changes, you can validate that your world is still consistent. And if that validation fails, the change never makes it in, your state is preserved, everything is sane and working, and it gets thrown out. So while in dev, you quickly catch errors, in production, you hook it up to your error reporting. And I've had this before where in Sentry proper, in Slack pops up a live user experienced something where the data I sent is of the wrong shape. And it's like an edge case that we never found in our testing. And that's absolutely great. And you can use this stuff for generative testing as well. So if you've ever seen the generative testing stuff that the Haskell and Erlang guys do, and it's easy to get jealous of the stuff, this gives the same foundation. So if you've got I can ask spec for give me a valid app DB, and it will go and generate something with a random number and a random string as values and go there. You told me this is what a valid data structure looks like, so there you go. So now if you want to build something with, rendering data, 1 million data points for some IoT events pipeline, you can just go write the specs for it, and at any time just say spec gen, give me 1 million of these things. And it'll spit it out and they'll all be valid, and you can work on your hard problem rather than fighting with the prod teams to get access to a database or some sample data. It's absolutely nuts. There's some great tooling around it. Refrisk is the debugger I showed you. It's absolutely great to work with. There's another up-and-coming one which is absolutely nuts. We'll show you super fine timing resolutions of what everything is doing, how long your event handlers took, how long your React components took to render and update. So if things aren't going well, it's a great, great tool to use. Or the irony of it is you can just roll your own. It's one of those bizarre things when you start working with functional programming. So these things become so pluggable that you just write what you need. An example of that is what I mentioned earlier. If you start collecting events and only keep like a queue of 50, and whenever you report errors, you ship them with. It's trivial to do. It makes it nice and easy. So who wants to go? It's on GitHub, day 8/reframe. This project is unique in that it has more documentation than code. It is exceptionally well done. If you've ever maintained your own open source library, go weep a bit at what these guys have made in terms of docs. They're serious about just teaching people. If you've got homebrew on your machine, it's as easy as brew install line again. It will sort out the rest, and you can generate a template. And otherwise, like I'm around, you can come chat to me. It's starting to grow in South Africa. We've got a bunch of companies working with us. We're doing some meetups. We hijack the Lambda luminaries every month. So there's definitely an opportunity. And I'm hiring if you want to make this your job. Thank you for your time. I've got 4 minutes. I don't know if we do questions, if somebody's got a burning question. Yeah?
So yeah, in the Angular world, the things like hot module reloading, they don't come standard with the framework. You showed a bit of hot loading there.
It's built in.
Is that part of the framework, is it?
Yeah, it's built into the toolchain. So even if you're doing any ClojureScript stuff, you'll get that. So you don't even need to use Reframe. You can use some of the other frameworks as well. But that hot code reloading, as I showed it there, is available to any ClojureScript project, no matter what. Even Node projects. I don't know how that works, but it's possible. It comes with it, stock. Anybody else have a question? The mic.
A specific kind of architecture?
You can make it.
Are there any guidelines on?
So the question is like, what if this is like MVC style or not? And it's not really. But you can. I think if you think of it more as an event sourcing model, that would make sense. Although you're not bringing the heavy baggage that comes with the words. You bring like the essence of the models. It's exactly that. It's just events that gets replayed over time. And the subscriptions become your view models or your queries into that world. And the two are completely segregated. There's like, so events the one way affects the world, reads the other way back until the user interacts. So definitely an event sourcing mindset would work the best. Cool, thanks everyone. Enjoy the conference.